We have data that gives the weight in pounds and cost in dollars of a sample of 11 stand mixers. This is from Consumer Reports in November 2005. In our class, oftentimes we'll pull actual data to show you how this stuff works. So what we did is we're going to enter in our weight in list 1, which is our explanatory variable, and our price in list 2, which is our response. So does the weight of this mixer influence what the price is on the mixer? So down below here, we're going to sketch a scatter plot and describe what you see. So as I do this, I type in all of my stuff into list 1, list 2. I can go into my calculator. After I've done that, my plots are on. I can go zoom 9 to get some idea of what, oh my goodness, that's not what I wanted. Sorry. Zoom 9. And we can see the graph on the scatter plot. You can check your window, all that kind of stuff. In my graph, again, because I don't want to check the window, I'm just going to draw one that kind of makes sense based on the information that I'm given. Don't forget to label your axes. So in this particular example, if I'm drawing my scatter plot, my explanatory variable was the weight, and it was in pounds. And then my response was the cost, and that was in dollars. And I'm going to go up by 50s, I think, maybe. Or maybe I'll just write down the hundreds here so you can just kind of see it. So here's 200, here's 300, here's 400, and then 100. Then I have the 50s in between. So you can see my scale. And then the weights go up to 35, so maybe by 5s. 5, 10, 15, 20, 25, 30, 35. So you can see what's going on there. And then I just start plotting my points. So I have 23, 180. And 28, 250. Again, my graph probably won't be as nice as yours. 19, 300. 17, 150. 25, 300. 26, 370. 21, 400. 32, 350. 16, 200. 17, 150. And 830. And as I look at these, it looks like to me that there's a average to strong positive linear correlation between these two things, the weight and the cost. We're going to calculate the correlation. So I go into my calculator and I go stat, calc. I'm going to use number 4. A linear regression. Enter. And I see that I have 0.741. So I write that down in my notes. 0.741. R equals 0.741. I would call this a strong, positive, linear association. Part C. The last mixer in the table is from Walmart. What happens to your correlation if you take out this point? I'm going to go into my calculator and I'm going to delete the last piece of information. Let's see what happens. So I go into my calculator, and in my list, I delete Okay, that's wonderful. Yeah, it's working really well. I got you. I hit delete. Do you see it?
So you have to
Go up.
Here, go up. Press the up arrow. Now go down.
Go down one.
Now
Now
don't
press
click enter, but just press the delete button.
Oh, nice. All right. Love it. Okay. Stat, calc, 4, enter. Whoa! 0.562. So now I go to 0.562 down here. This now. So the correlation changed to 0.562 from 0.741. That's what happened. What happens to the correlation if the Walmart mixer instead is 25 pounds instead of 8 pounds? Or in other words, you had the 0.2530. So let's check that out. Go into my calculator. Stat, enter. I'm going to go down and enter in my last point being 2530. And then go stat, calc, number 4, enter. And now my correlate, holy moly, my correlation is 0.336. So I write that down. 0.336 is the new correlation from 0.741 originally. So you're comparing your original correlation to the one you currently have. And then the last point that they're talking about is, whoa, let's suppose that a new titanium mixer is introduced. It's 8 pounds, but the cost is $500. So now let's get rid of that 2530 and instead put in the 0.8500 and see what happens.
Press enter.
So stat, calc, 4, enter. My new correlation is now, whoa, negative 0.077. Negative 0.077 is the new correlation. I'm not going to write down the rest of the stuff that I did before. What patterns do you see? So let's see here. 1 point can drastically change the correlation even from a positive value to a negative value. So be careful about this data. One outlier can cause a major change.